Binomials. So we're 14-6 multiplying. So I see a lot of things going on back there, and it shouldn't be happening because you're distracting others. Multiplying binomials. Does anyone remember what a binomial is? It's a binomial. Michael? Good. Two monomials are being either added or subtracted. Good. So a binomial is a polynomial with how many terms? 2. So that's what the whole point of the name binomial. And then we're multiplying them. But I want us just to multiply a problem we've done before. I want you guys to work out 43 times 17. Just go ahead and multiply that out any way you know how to, other than a calculator. Unless it's in your brain, that's cool. But I need to see the work. So multiply it out. 43 times 17. Don't give the answer yet. Sorry. Wait a little bit, and then I'm going to come back to this problem after we verify the answer. Make sure you guys all got it. And then I'm going to see, is there another way to do it? And I will answer that later. But let's see if we can get this problem here, which hopefully all of you can get. Okay, another 10 seconds, and then we'll get that answer. We get 731. 731. Okay, what I need you to do here, guys, is I need you to leave a blank off to the right. Not too big, but the same amount of room you took for this problem, you need that same amount of space in your notes for later. Actually, toward the end of the lesson, I'm going to give you another way of doing it, okay? So how many of you got 731? Please raise your hand. 731. And if you didn't, hopefully it was just like a little mistake, not a critical error. Okay, let's look at example number 1, and let's see how to multiply those two binomials. So example number 1A. Example 1A. So write down those binomials. 2x plus 3 times 3x plus 5. Okay. There are a couple ways you can think of this problem. I'm going to give you the long way of doing it and then the shortcut, the little acronym that we use to figure these ones out. And then we're going to simplify our answer to make sure it's as simple as can be, because that's always a good thing in math. Look at it for a while. Kind of wonder, like, I don't know. How many of you would agree that I could use a distributive property? Like, you see that it might be useful in this problem. Distributive property? Okay, some of you may see it. Okay, basically what I would do, and this is a long way, I would multiply this polynomial by each one of these. Does that kind of make sense? Like I would multiply this by 3x and this by 5. Oh, close, you're getting there. Okay, how many of you would, like, you get that by distributive property? You're kind of like, the hard part about it is, whoa, that's like two things multiplied by 3x. So this is how I rewrite it. I'm going to rewrite it 2x plus 3 times 3x. 2x plus 3 times 3x. Right? Isn't that what that is? And then I also have to add to that 2x plus 3 times 5. Ugh, this is already looking kind of rough, isn't it? I mean, it's kind of complicated. But do you guys see that I multiplied 2x plus 3 times 3x right here? Do you guys see that? And I did 2x plus 3 times 5 right here. You guys okay with that? Because I don't want to make stuff up. Jensen?
You use the associative property and make it so that way the parentheses is just 2x plus 3x and then times.
The way you could do that is if I had a plus sign here. If I had a plus sign here, I could do what you're saying. But I have addition and addition, but then they're being multiplied, so I can't cross over like that. But that's a good thought. I wish I could do that. That'd be cool. Okay, now if you're looking at this right here, does this look like a familiar problem? Does it look like any of those? Ready? Can I rewrite it? Does that look like that problem? Can you guys do that for me real quick? I'll show you the hack in just a bit, but not yet. So go ahead and work this one out. Work this distributive property out. It's like, what? Well, you're going to do 3x times 2x and 3x times positive 3. So who can tell me what's 3x times 2x? Marissa? 6x squared. What's 3x times 3? Elizabeth?
Well, I have a question.
Yep.
Can't you just multiply 2x times 3x and then 3 times 5?
My son Titus is grinding his teeth. We don't know why he does it, but I want to grind my teeth right now. No, you're getting there. We'll get to that. Did you read my hack? My strategy for math hacks? Okay, bummer. Okay, you're getting there, Elizabeth. What's 3x times 3?
9x.
Positive 9x. Good. Okay, that's how you do the first distribution. The second distribution can be written like this. So positive 5 times 2x plus 3. I mean, isn't that how it could have been written? 5 times 2x plus 3. And if so, I can use the distributive property there. 5 times 2x is what? 5 times 2x is 10x. Positive 10x. And 5 times 3, or 5 times positive 3 is? Yep. Positive 15. Oh, nice. So I have these two distributions, and what can I do with them? Add them together. Are there any like terms in these four? What are the like terms? Ooh, the debate continues. Okay, can we do this? I'll walk you step by step. Does 6x squared have a like term? 6x squared. No, so I'm just going to write it. It stays by itself, 6x squared. Does 9x have a like term?
Yes.
The 9x combines with the 10x to make?
19x squared.
Ooh. Positive 19x. Yeah, because we're just adding these two together. We're just adding them. If we were multiplying them, we'd get 90x squared. That's not what we get. But we're just adding them. Good. And then does 15 have a like term? This is my answer. It's a trinomial. We'll do more of them. So, yeah, it's not.
Other way, I don't get how you do it. Like, there is no other way.
Yes, ma'am?
But if you didn't, instead of multiplying binomial by continuous monomials, and you just did 2x times 3x and then 3 times 5, you wouldn't get the same answer.
That was on camera. I'm going to have to delete that part. Okay, Caroline, if we do it another way, hopefully we get the same answer, right? But how many of you are, write this answer down so that we have a reference point. There is another way to do it. It is using an acronym, and hopefully we get the same thing, because if we don't, something's off. I got to go back to the beginning of the lesson, reteach it, and then that's just messy. Okay, everyone, I hope, has this written down, right? Everyone has this written down? Let me show you a little pattern here when you're multiplying these two binomials together. And I think Elizabeth and Caroline, you're both talking about it. Did I do 2x times 3x anywhere? Did I multiply 2x and 3x anywhere?
Yes.
Where was it?
9x and 10x.
It's right here, sorry.
Oh.
Yeah, that's okay. Did I multiply 2x and 5 anywhere?
Yeah.
2x and 5.
Right beside that.
Right here? Did I multiply 3 and 3x anywhere?
Yes, right there.
Right here you can see. And did I multiply 3 and 5 anywhere?
On the left.
Right here, right there, right there. Yeah, let's make life easier for ourselves. We could distribute many times, or 2 times in this case, but there's got to be an easier way. So what I'm going to do is this. I'm going to erase all this work. Oh, man. It's so sad. Seeing all your work up here just like disappear when you work so hard for it, it's just really sad. I didn't mean to do that. Oh, all right. Here's the acronym, and you guys have this, so I'm going to erase it. It's called FOIL. FOIL is one of my favorite things to do in math because it makes this problem so much easier.
Yes.
Okay, what you need to do in this problem is identify terms. Have we done that before?
Yes.
Okay, can somebody tell me what the 2 terms in the first binomial are? Give me the sign and their number and variable. Sophie?
Positive 2x plus 3x.
Okay, sorry, positive 2x and positive 3. Those are the 2 terms. Second 2 terms, or the next 2 terms. Jensen? Positive 3x and positive 5. All right, you guys good on that? Because if you know those, FOIL's good.
Yay.
F stands for first. You're going to multiply the first terms in each binomial. The first term in each binomial. What's the first term in the first binomial?
2x.
What's the first term in the second binomial?
3x.
So first you're going to do 2x times 3x. And what's that? Oh, 6x squared. That's where you are. So you guys okay with that? 6x squared is first. O stands for outer. Outer. The outer terms. Does anyone want to guess on what the outer terms are? Raise your hand. They'll just call out. What are the outer? What do I mean by outer terms? Like, what do I mean by outer terms? John?
Is that like the 2x and the positive 5?
2x and the positive 5 is correct. So what's 2x times positive 5? Positive 10x. Okay, that's nice. That's nice. I stands for? Inner. Inner terms. Inner terms. I know what the outer terms are, but I don't know what the inner terms are, or do I? Max? 3 and 3x. So what's 3, or positive 3 times positive 3x? Positive 9x. Man, these terms look familiar. And L stands for? Last. L stands for last. Okay, so what are the last terms in each binomial, Michael? Positive 3 and positive 5. What's positive 3 times positive 5? Positive 15. Can I make this any simpler?
Yes.
Emma Grace, what do you think? Can I make that simpler?
You can add the
Positive 10x and positive 9x gives me what, Jack? Oh, there you go. Very good. Positive 19x. Okay, hold on, guys. Hold on. Uh-oh. Marissa? Yeah, can I ask you a question first? Is this the same answer we got the first way? Oh, that's interesting, huh? Very interesting. Go ahead.
Okay, I still don't understand why it wouldn't be 19x squared.
Okay. When you change the exponents of these terms, you're multiplying those terms. So like if you did 10x times 9x, you would get 10 times 9 is 90, x squared. That's when you're multiplying them. But what's going on between these two? You're adding them. So do you change the exponents when you add like terms? No, never. So when you're adding like terms, do not change those exponents. Maybe that can help out. All right, Jensen?
Does this not work for trinomials?
Oh! Can it work? Well, you mean FOIL or this process? FOIL will not work for trinomials.
What about polynomials?
Well, if they're binomials, yes. If they're monomials, no. If they're trinomials, no. If they're binomial, trinomial, binomial, monomial, binomial, polynomial. Okay. It only works for 2 binomials. Now, let me ask you this question. I have a whole lesson on multiplying binomials. Do you think those binomials are important? You're going to see binomials a lot. In fact, before John's question, Here's my answer, and I got that already, right? We already have that. This right here is going to be next year given to you. They're going to give you this. And you know what they want from you? They want you to tell me what binomials multiply to get me that. You're going to have to work backwards. Not yet. That's next year. And that's after a lot of chapters. We'll get to that. In fact, it's cool because I gave it to the 8th graders, and we were starting to factor. That's what you call factoring, going from that to the binomials. And at first, like, what? And then they're doing it. And after a while, we have it still in this chapter, factoring. And I'm like, all right, guys, remember we got to factor? Oh, yeah. They do it. Just get it. They start doing it. But does it take a while to get to that mindset and get used to it? Of course it does. All right, John, question.
I forgot my question.
That's okay. I'm sorry. If you remember, raise your hand. Yes, ma'am.
Is that your honors class that does that?
Both classes will do. Yeah. So you'll have fun. They'll have fun.
I'll just
No matter what class you're in.
You know, you won't find me.
Oh, I might not find you, but someone will.
Josie girl. You ain't finding us.
Yeah, who is it?
You couldn't find you.
Okay, let's do something interesting. I said it was at the end of class, but I'm going to do it right now. Do you remember this problem here?
Yes, I did.
I'm gonna use FOIL on this problem here, but you're like, FOIL? How can you use FOIL? There's no binomial. This is what I'm going to do here, guys. Listen carefully. I need you to write this down. It's the same problem, but I'm going to write it. Instead of 43, I'm going to do 40 plus 3. And instead of 17, guess what I'm going to do? 10 plus 7. Okay. Can I use FOIL on that now? Absolutely. It's a binomial and a binomial. I could have added these together to get back to my 43 and back to my 17, but watch what happens. What's the first term? What are the first terms multiplied? 40 and 10 give me 400. Okay, that's F. That's first. Okay? Outside or outer would be what? 40 and 7? What's 40 times 7?
280.
280. Good. And these are good because they help. They're like, oh, I can do 40 times 7. That's, 280. It's 28 with that 0 added. Inner terms are positive 3 and 10, which give me 30. Okay, I got my 30 there. And my last terms of each binomial, 3 times 7, would give me 21. What do I do with all these? I add them up. What do they give me?
731. This is hack.
That's not a hack. You have to do 4 multiplications and you have to do on the first one.
What? No way. I prayed like this because I wanted you guys to know you've done this so many times before you don't even know it. You've used FOIL so many times. You've used it in this process right here. This process is FOIL, and the extension of FOIL is also there. So here, basically what you're getting is, what's 280 plus 21? 301. What's 400 times or plus 30?
430.
You did it already. You did it already. You've been doing it already. You've been doing it for many years already. You've been using FOIL, you just didn't know it. Okay? Which is really cool because when I figured that out, I was like, wait, I hate FOIL. No, I love FOIL. I use it all the time. Because if I told you to work this problem out, no one's going to do this. 43 times 17, and you're doing some weird. You're just going to write it down like that and get your answer. Oops. And that's what you get. Okay, let's work out a couple more so we're used to it. Let's go to example B. 2x plus 1 times 5x minus 3. So this is B on example 1. 2x plus 1 times 5x minus 3. Okay, I'm going to call in different people to give me the first terms, outer terms, inner terms, last terms. And then some other people to give me what they are multiplied to, what did they multiply to get me? Well, what is the product of those two first terms, outer terms, inner terms, last terms? Okay, I just want to know what are the first terms, Callie? What are the first terms?
Is it 2x and 5x?
Okay, 2x and 5x is correct. What is 2x times 5x? Josie? 10x squared. Very nice. 10x squared are my first. And I'll put an F here. That's FOIL. 10x squared. Okay, what are my outer terms? Emma Grace, what are my outer terms? 2x and negative 3. What's 2x times negative 3, Mackenzie?
6x.
Close? Sign. Negative 6x. So that's my outer terms right there. Negative 6x. What are my inner terms? Jack, what are my inner terms?
1 and positive 5x.
Okay, 1 and positive 5x. What's 1 times 5x? Sydney? 1 times 5x. Positive 1 times 5x. Good. Positive 5x, and that was my set of inner terms. Last terms, Timothy, were or are?
Positive 1 and negative 3.
All right, positive 1 and negative 3. What are those multiplied together? Braden.
Wait, the last terms, that would be negative 3.
Negative 3. Those are my last terms. Okay. Are there any like terms in these 4 terms that I got when I multiply? Are there any like terms?
Yes.
Okay, Elizabeth?
Negative x and positive 5x.
So negative 6x and positive 5x. Okay. So these 2 terms, bless you, can be added, and what do they give me? What's negative 6x plus 5x? Max? Negative 1x. So I'm left with 10x squared minus x minus 3. That's what I'm left with in simplest form. Do you guys see any patterns so far? When I usually, and I don't want to say always because that's not true, usually when I multiply 2 binomials, I end up with a trinomial. That's a pattern, and we're going to be able to go from trinomial to binomials next year.
So for last, 1 positive 1
Times negative 3?
times.
That gets me right. That's okay. So you're multiplying these. These are being multiplied. These are being multiplied. These are being multiplied. Those are being multiplied. And then you'll get your products added in like terms. How many of you are pretty good on this, you think? You're like, how many of you like FOIL, by the way? I like FOIL.
My plans.
Jack, were you waiting to say that for
No,
one?
but
Okay.
I got it from McKinney, so I just felt like I was
Oh, all right. Good. I'm glad the writer and the actor gave it their all on that one. Okay. I want you to go to page 730. And to test to see if you know it, I need you to work out number. We'll go with number 9. 730. Number 9. 730. And like I said before, you're using the distributive property, but basically on these problems you're doing it twice. You're distributing twice. There's just a nice little method of doing it. It's called FOIL. Okay, check with your neighbor, please, the person next to you. See what you guys got. Compare your answers. Okay, either you got the same thing and you're both right. You got the same thing and you're both wrong. Or you got different things and one of you is right, one of you is wrong, or both of you is wrong.
Or we're all right. That's not possible.
That is all right. Because the answer number 9 is, somebody want to share it with me? Josie, what do you have?
2x squared plus 5x plus 3.
Very nice. 2x squared plus 5x plus 3.
Yay!
Yes, ma'am?
Couldn't you add 2x, or both 2x's and the 3x?
To make it
I have, you can add 2x and 3x, and that makes it 5x.
But then there's
2x plus 5.
There's another 2x.
squared.
I think it's squared, yeah. Because x times x is x squared. That's okay. Okay. Your homework tonight, that's it. 17 to 31. No, that is not right. I think it's 17. Oh, 17 to 27 odd. And then 34 and 39. And thankfully we are done with testing, so for you guys I think it's more normal for the class schedule. But as you guys were working that last problem, I do want to say I am very proud of you guys for your thinking. You're thinking so well. Before I even brought up foil, you guys are already telling me, Mr. A, wouldn't faux be good? You gave me faux. You didn't give me oil, foil, but you gave me the first one. I'm like, yep, you're starting to think about it well. And then we can come up with it and it makes sense. But keep working on your thinking. Like, keep thinking, keep asking good questions. You'll do well. 17 to 27 odd. And then numbers 34 and 39 toward the bottom of the page. Okay, goodbye, Swivl.